Okay, hopefully you were able to find all of the formulas involving polygons after doing the investigation, but just in case, we're going to go through each one. So when you have a triangle, there are no diagonals that can be drawn from the vertex. So there is just one triangle altogether, and we know that the sum of the angles of a triangle is 180. When you have a quadrilateral or four sides, if I draw on the diagonal from one vertex, you can see that it makes two triangles. Right? And so if we were to take the 180 degrees from this first triangle and add it to the 180 degrees from the second triangle, we would see that altogether the angles of the quadrilateral add up to 360. When we have a pentagon, we are able to create three triangles. And so if we were to add up all of the angles of those triangles, it would make all of the interior angles of our pentagon, and that would sum then to 540. Here, if I draw all of the diagonals from this vertex here, I end up with four triangles, and so 4 times 180 would be 720. And then finally, hopefully you see the pattern by now, there would be 5 here, and then the sum of the angles would be 900. And so then if I go back and I look at the number of sides versus the number of triangles that I'm able to draw, I can see that there's a difference of 2. So there are always going to be n minus 2 triangles that are drawn, and then to find the sum of the interior angles of the n-gon, it's n minus 2 times 180. Okay. So that's the first formula you need to know, that the sum of the interior angles of a polygon or an n-gon is n minus 2 times 180. All right, now if we look at the exterior angles of an n-gon, let's start with the triangle. And I'm just going to do some numerical examples here. 20, 120, and 40 might be a triangle. So then here's one exterior angle. I know that would be 140 because they are supplementary. So here I have another exterior angle. Its value would be 160. Here is an exterior angle. Its value would be 60. And if I add those up, I find out that it's equal to 360. Okay. And that was 180 for the sum of the interior angles. Let's try another triangle. Let's just look at an equilateral triangle. 60, 60, 60. This is 120. This is at 120. This is 120. So 120 times 3 is 360. All right, so it looks like no matter which size angles we have, the sum of the interior and exterior angles is going to be 360. Now let's look at a rectangle, because that's a type of quadrilateral. We know that the sum of the interior angles is 360, but let's look at the exterior angles. When you're looking at exterior angles, you want to look at one per angle. So this would be 90, this would be 90. My exterior angle is right here, it's 90, and here it's 90. And so here I have 4 90-degree angles, and so the sum of my exterior angles is 360 there. If you were to do the same thing with a pentagon, you would also find that the sum of the exterior angles is 360. So no matter how many sides a polygon has, the sum of the exterior angles, one per vertex, is always going to be 360. So a quick proof of that, just to show that it is always going to work. Let's start with just a quadrilateral and then we'll extend it. Okay, so I'm going to label these X, Y, Z, and W. So this exterior angle is 180 minus X. This exterior, that one is 180 minus W. This exterior angle is 180 minus X. This exterior angle is 180 minus Y. And this exterior angle is 180 minus Z. So if I were to add those all up, I have 180 minus W plus 180 minus X plus 180 minus Y plus 180 minus Z. That's going to equal 4 times 180 minus w plus x plus y plus z, so I just factored. So that gives me 4 times 180, and I know that since this figure is a quadrilateral, the sum of the interior angles, which is w plus x plus y plus z, is 360, so that's going to end up equaling 360. So extending it to in general, I'm going to have n times 180 minus the sum of the interior angles, because that's how many, that would be the measure of all of the angles at each vertex. And so then just doing the algebra here, we have 180n minus 180n plus 360. These two make 0, and so we're just left with 360. So the sum of the interior angles of any n-gon is 360. Finally, looking at the angles, are the diagonals. Triangles don't have any diagonals. Quadrilaterals, when you draw those, there are 2. Okay. When you draw a pentagon, okay, what ends up happening is that at each vertex, you can draw a certain number of diagonals. At 5, there are 2 that can be drawn from each vertex. At 6, there are, I drew another pentagon. At 6, there are 3 diagonals that can be drawn. So there's always going to be n minus 3 diagonals at each vertex. So for each vertex, you have n, and then n vertices. Then there's going to be n minus 3 diagonals from each one. But then what happens when you start moving around is when I come here, I've already counted this one. And so at each vertex, each diagonal can end up being double counted. And so we end up having to divide by 2. So the formula is n times n minus 3 over 2. So the answers here would have been 5, 9, and 14. So this is the formula for the number of diagonals for an n-gon. So it's n times n minus 3 divided by 2. Now in this unit, you're also going to need to know the names of the various polygons. Most of them you already know. They are on page 307 in your textbook. So a 3-sided polygon is a triangle, a 4-sided polygon is a quadrilateral, 5 sides is a pentagon, 6 sides is a hexagon, 7 is a heptagon, 8 an octagon, 9 is a nonagon, 10 is a decagon, 12 is a dodecagon, 15 is a pentadecagon, and just in general, an n-sided polygon is called an n-gon. Make sure you can go both ways. If I tell you that the figure has 10 sides, you need to know that it's a decagon, and you need to go backwards. If I tell you that it's a pentadecagon, you need to tell me that be able to tell me it has 15 sides. So make sure you know the names of your various polygons. All right, so then finally an example that shows the use of all of the formulas. If I want to know the sum of the interior angles for a 23-gon, well, the formula is n minus 2 times 180. So that would be 23 minus 2 times 180, which is 3,780. If I want to know the sum of the exterior angles of a 23-gon, well, that's always 360. It doesn't matter how many sides it has. And then if I want to know the number of diagonals for a 23-gon, that would be n times n minus 3 over 2. And so then that would be 23 times 23 minus 3 over 2. So that's 23 times 20 over 2, and that gives me 230. So these are the 3 formulas you need to know. Sum of the interior angles is n minus 2 times 180. The sum of the exterior angles is 360, and the number of diagonals in an n-gon is n times n minus 3 divided by 2.